What's up, chicos y chicas? Chapter 14, Section 1, Ratios and Symbol Rates. Oh, ratios and rates, your favorite content that you've already forgotten. I'm just joking. No, actually, I'm not. What's a unit rate again? See, that's why I made this the essential question, because y'all are running around going, I know what a unit rate is. You know what it is in January. And then you go, I forgot what it is in May. So we're going to go back over what that is. Okay, just a quick review. A ratio is a comparison of two quantities using division. 3 to 4, 3 to 4, 3 to 4. These are all the exact same ratio written in different forms. Fraction form with the word 2 and with a colon. So you might have like, I don't know, 3 SpongeBobs to every 4 Patricks, right? A rate is a ratio of two quantities with different units. And that might have been confusing because it's like, well, if this is SpongeBob's 3 and Patrick's 4, aren't those different units? What they really mean is different unit domains. So 60 miles is a distance domain. 2 hours is a time domain. So they're in two different domains: miles, distance, and hours, time. So this is a rate. So rate is a ratio. It just has those different time domains. And finally, a rate with a denominator of 1 is a unit rate. So instead of 60 miles for every 2 hours, we would never say that. Hey, Mom, how fast are you driving? 60 miles per 2 hours. No one would say that. They would use a unit rate, and to get to a unit rate, you want to divide the denominator by whatever number it would you need, whatever divisor you need to get 1. 2 divided by 2 is 1. The hours stay the same. We now must divide the numerator by 2 as well, because we're really dividing by 2 over 2, which is dividing by 1, and that doesn't change the value. 60 divided by 2 is 30 miles per hour. That is a unit rate. Hopefully you remember this. The word unit is singular, so there's only one of them, right? 30 miles per hour. And just because I know some of you are completists and you want everything highlighted, there you go. That was for you, because you needed it. Okay, that's great. I'm going to need you. You know people who say that? I'm going to need you to do this. It's like, oh, man, it's rough. All right, first question. How do I find a ratio or a rate? How do I find how do I find a ratio or rate? There are 45 males and 60 females in a subway car. The subway car travels 2.5 miles in 5 minutes. Interessante. Find the ratio of males to females. Okay, order. Does it matter in a ratio? Yes. Males, 45. Hey, look, there's the word 2. That indicates that this is a ratio. 45 to 60 females. So all we do is just substitute the value, the number that goes along with males, 45, the number that goes along with females, 60, and we have the 2 in between. Remember, this is only one of the forms. One of the other forms, you could use a colon, and that would be equally right. Here's another ratio. And of course, you could write it as a fraction. These are the different forms of ratios. We have colon, 2, fraction. Okay, find the speed of the subway car. Well, if it's going 2.5 miles in 5 minutes, speed, we know something about that. The speed of an object is equal to the ratio of distance to time. So all we need to do is substitute the value for distance, 2.5 miles, to 5 minutes, the time we substitute 5 minutes in. Okay, now it does not ask for a unit rate. So technically, we are done. However, just to remind you, we usually don't write speed as with having 5 minutes or 2 hours or whatever in the denominator. We want a unit rate. We want per minute, how far is it going? And to do that, you divide 5 by, I can hear you. I can hear you out there, 5. And if you divide the denominator by 5, you must divide the numerator by 5. Beautiful. Okay. Well, 5 goes into 25 5 times, but that 5 is going to be on the right side of the decimal. So that's going to be 0.5 miles per minute, which actually makes sense, right? 5 minutes, you go down to 1 minute, and that's going to be 1/5 of 2.5, which is about 0.5. That's how fast the subway car is traveling. When writing a ratio, the blank matters. The order matters. You would never write part A's ratio as 60 to 45 because it's males to females, so it's 45 to 60. The first number in the ratio is the dividend, and the second is the divisor. Whatever you divide by is the divisor. Typically, time goes in the denominator of a rate. Typically, it's in the denominator. So when you can remember that, if you think about, hey, how fast do we go in this car? 60 miles per hour. Per means divide, hours in the denominator. Speed is typically written as a blank rate. What kind of rate is this? A unit rate. I can't believe how good you're all doing, actually. Honestly, right now, I can't believe how good I'm doing. Yeah, whatever, I know. You probably want my autograph. No, I know you don't. You're like, no, actually, I don't. I don't want your autograph. Get out of here. Fine, geez, ow, gosh, my heart. How do I use a ratio table to determine the rate? Okay, the ratio table shows the costs for different amounts of artificial turf. Do you guys even know what that is? It's like fake grass. It's like in the backyard, like fake grass. It's the stuff baseball players used to complain about playing on because it would injure them. Anyways, find the unit rate in dollars per divided by square foot. Okay, dollars, money typically goes in the numerator, but look at how this table's oriented. The amount, the feet squared, right? Because we're talking about area, is in the top and cost in the bottom. So we're going to want to flip these numbers when we actually write the unit rate. Well, let's see. Yeah, 25 feet squared is $100. 100, well, that's 4 times as much. So yes, $400. So this looks like it's proportional, right? Equal fractions. 100 times 4 is 400. 400 times 4 is 1,600 or 1,600. 400 times 4 is 1,600 or 1,600. 1,600 times 4 is 6,400 because 16 times 4 is 64. But we want a unit rate in dollars per square foot. So cost dollars, how about 100 over 25? So $100. And we almost always put money in the numerator, and then we're going to put 25 feet squared in the denominator. We want a unit rate, so what do we want in the denominator? Just like the essential question reminds you of, hey, yeah, what's a unit rate? 1 in the denominator. We want per 1 square foot, or 1 foot squared. How do we do that? We divide by 25 in the denominator. We must divide by 25 in the numerator, and you find that it's $25 every square foot. Money typically goes in the blank of a rate, the numerator. It's $5 for one super avocado. Actually, with the rate at which avocados are increasing in price thanks to those millennials treating it like it's the only thing that they can eat all day long. Those millennials. I think I am a millennial. That's all right, whatever. I don't like labels. Okay, how do I find a rate from a graph? The graph shows the speed of a subway car. What's up with the subway cars? We only have, the only subway around here makes sandwiches. All right, find the speed in miles per minute. Hey, look at that. Time goes in the denominator. And then we're going to compare the speed to the speed of a subway car, or the speed in the subway car in the top example, okay, of these notes. I believe the top example had, top example, it was something like 0.5 miles per minute. So let's keep that in mind per 1 minute. Okay, and we are now going to do this one. Well, oh geez, we have ordered pairs. This is so hard. It's actually not. If we want, where is it? Miles per minute. We look at the labels on the axes. Miles is the y-axis. Minutes is the x-axis, and that dot was done accidentally, so we're just going to accidentally. Anyways, we're just going to leave it there. Okay, so if it's distance y value over time, minutes x value, we want 1/4 over 1/2, or 1 1/2 over 3, or any other ordered pair with its y value over its x value. How do we know that these ordered pairs are going to be proportional, equal fractions? Remember, if it's a line, well, you haven't done this yet, but actually I've already filmed the video. But if it's a line and it starts at 0, 0, we know that these ordered pairs are proportional. That's a later lesson, never mind. So we're going to take our y value, okay? So the new example, we put 1/4, the y value, which is the distance, over the x value, which is the time. I know this looks weird. I call it a frackwich, but it's really called a complex fraction. Now this is 1/4 of a mile, the y value, over the x value, per 1/2 minute. And I'm going to try to write a little better because that's really bad. This thing's all trending upward. Okay. Do we usually write speed as a complex fraction? No, we want 1 in the denominator. We want 1 minute. And why do we want a unit rate? So we can compare it to the top example. How do I get from 1/2 to 1? I multiply by 2. So now I have to multiply 1/4 by 2, and I get la-di-da 1/2, written more affectionately as 0.5 miles per minute. The speeds are the same. That's amazing. I know, you're amazed. Are the same. Oh, can he do it? Can he squash all these letters together? Ooh, exclamation point. That's really weird looking. All right, anyway. Speed is blank per unit of blank. Is distance, I'm too lazy to write the whole thing, dist, per unit of time. So, so we want to divide the y value by the x value. It's like slope, which you're going to learn about later. A unit rate has a blank in the denominator, a 1. Back to the essential question. So you'll need to blank the numerator and denominator by the same factor to get the unit rate. Multiply. Oh, I'm doing the whole word. I go the extra mile for you guys. All right, everybody, that's it for rates and ratios. I hope you've enjoyed this video. If you really want it to, you can subscribe down there in the comments, and then you can see all my videos all the time. Oh my gosh, bye.